Hi, good afternoon. This is Mr. Cassidy, and today we're covering 2.5 and 2.6, our study guide. Our final test in this section is going to be on Thursday and Friday of this week, and I hope this helps you prepare. Again, to use this, I would go skip ahead to the ones you got wrong and watch how to solve those. But if you need bigger overview questions, those will be addressed at certain points in the video as well. Let's jump into it. So the first problem we have is this one. Select a compound inequality that does not belong with the other three. So on each of these, what I would do is I'd sort of brainstorm. And I'm going to go, okay, A is greater than 4. Let's imagine 4 is here. That's something like this. And A is less than -3. That would look like this. The second one, they're all or, so I'm going to keep looking for what's different. A is greater than 8. That's going to be like that. And A is less than -2. Well, that's sort of similar. 8 and -2 are just the numbers where they are. Here I have A is greater than 7, so that's like that again, and A is less than -5. That's like that. Then the last one, A is less than 6, so that would be like that. And -9, A is greater than -9. So the only one that doesn't belong is this last one. Because in this one, it's the only one with opposite rays that overlap or crisscross each other. I'm not sure what the drop-down menu has, but it's something along those lines. They are opposite rays that overlap. Okay, problem 2. Write the sentence as an inequality. M is more than, so I'll write M more than. Now remember, when you type that in, you have to use the correct letter on Big Ideas. They're picky about that. M is more than -7 2/3, so -7 2/3. Or, well, let me pause and write my or right now. Or M is at most -10. Well, at most we know is less than or equal to -10. Equal to -10. Because M is at most, that means the most M can be is -10. M is always less than or equal to it. So I would go ahead and fill in each of these in the inequalities here. And to graph that, we need to pick each one. So the first one, M is greater than -7 2/3. That's going to be an open dot because less ink, and an arrow to the right because it's greater than. And -7, do be careful here counting. We have to start at -7. -7 1/3 would be here. -7 2/3 would be here. And that's where we're going to put the solution. Okay, or M is less than or equal to -10. Remember how we can graph that. More ink, so that's going to be a solid dot. And we can use that arrow trick because M is on the left and fill that in. So that's going to be a solid dot with the arrow to the left. Okay, next problem. Problem 3, write a compound inequality that's represented in the graph. This is a good point to introduce. Anytime the arrows are pointing out words, that's when it is or. Anytime we have like a barbell here, something like this, maybe it's half open, half closed, that's going to be an and situation. So I have an and compound inequality. Let's go and brainstorm each one. X, and so here I've got 3, and I know that this arrow from 3 is going to the right, so I try to draw the arrow, but I just leave out the inside, and it's a less ink situation, so I'm not going to use the equal to. Here, X and 2 is my border. It's a solid dot, so it will be more ink, and the arrow would be going to the left, so I draw that arrow without the middle bit, and I get X is less than 2. However, they're asking for the compound inequality and they only give us one box to write in. So you can't use the word and. So we need to change it to its compact form. Remember, you may have noticed that I made a mistake. That should be a -3. We need to go least to greatest. So the smallest number, that's the border, is the -3. So I do -3. That is with the small side, the less than side of X. And then I've copied the other one. That would fill in our box there. Okay, number 4, match x is greater than or equal to -2 with its graph. Well, solid dot, arrow to the right. It looks like it's B. Okay, we've covered this, I feel like, pretty well. All right, number 5, solve the inequality. Well, we need to solve them separately. So number 5 is a bit of a doozy. And guys, this goes a bit beyond what I'm expecting. I'm going to go ahead and solve it now, but please know that this is not on the test. You might need to solve a compound inequality like this, but it would not give us, because I believe this one gives us one of these two answers. Let's solve it anyways. So I'm going to add the 8 to both sides, and I'm going to get x is less than or equal to 12. Or, bring down our or, now start solving the other. I'm going to subtract 3 from both sides. That gives me, I'm going to write it down here, 2x is greater than 6, divide by 2. And I get x is greater than 3. So what does that mean? Well, you know, it would be very easy to try to find that solution, and I see that it looks like this would be correct. The only problem with it is that this is an or inequality. We don't have, remember, this would mean and. This usually means x is between two numbers, but this is an or. So that's not right. Because this would mean it's not any bigger than 12 or less than 3. And I can't pick two options. So sort of all the rest of these are out. So now I need to decide which is it. Well, the best way to do that is to brainstorm. Here's 3, here's 12. Let's brainstorm above. X is less than or equal to 12. That's going to be an arrow to the left. And x is greater than 3, or x is greater than 3. Well, what happens when I have the solution here is, well, we're going to draw the solution wherever x can be, or any of the solution lines. It doesn't look like I can change the color, but I would shade in the whole number line, because no matter what x is, it will be either less than or equal to 12 or greater than or equal to 3. So we get all real numbers here. X will always work in this inequality because it'll be true for one of them no matter what. Even if it's less than 3, it's still less than -12. Even if it's greater than 12, it is greater than 3. So it will always be true for one of them. But again, this is a little beyond, but our solution is all real numbers. Okay, problem 6. Here's a more straightforward one. Remember, our trick for this is if we're going to subtract 5 to isolate our x, we need to subtract 5 on both sides. I get 1 less than x, which is less than or equal to 6. And that's what we would put in our solution box here. Now we need to graph that. That would be a open dot at 1 with an arrow to the right because x is bigger than it. Remember, if it helps you to split this up, to graph it, you split this up and you could switch it around and do x is greater than 1. That means open circle at 1, here's 1, and an arrow to the right. Here I have also x and x is less than or equal to 6. That's going to be a closed dot here, and I want the overlap. So I want the one that has a closed dot on the right, open dot on the left, and I'm going to solve it just like this. The overlap is where those lines meet. Okay. Problem 7. Describe the error in solving the inequality or graphing the solution. So here they subtract 3 from both sides, and that looks pretty good. Oh, no, wait. I found it already. Subtract 3. They subtract 3, but they forget to subtract 3 here. We should have 1 there. Okay, so I'm going to go ahead and copy what they should have done. And let's find that. In the second step, 4 should have been subtracted from the right side. No, wait, that's not quite right. In the second step, 3 should have been subtracted from 4 on the left side. That's our correct answer there. This one's the wrong number. See, it shouldn't have been 4 being subtracted. It was subtracting 3. So to solve it, though, I'm going to divide by a -2. And that does mean reversing the symbol on each of these. So I get -1/2 is greater than x is greater than -3. Okay, so to graph that, that looks like a compound inequality with and. But the only problem is, oh, and by the way, that compact version should go right there. If they just give you one box, that means you need to put the compact one there. It can't read words like and or. It would give you two boxes if it was or. So let me rearrange this into numerical order. Negative 3 is less than x is less than negative 1/2. And I'm going to split those up. So I'm going to graph each one separately. I'm going to split up the first. So it looks like x is actually greater than negative 3. So here would be an open circle arrow to the right. The other side of it, if we split it up, is x is less than negative 1/2. Well, that's going to be open circle arrow to the left. Negative 1/2, remember that would be 0, 1/2, 1. So that would be here. And I would pick the one with two open circles meeting in the middle. Okay. All right. Problem 8. Solve the inequality. Well, we want to solve from the inside. Start with subtracting 4. I believe this might also lead to an error, but let's get there. I get 18. Yes, that's right. Less than negative 3c is less than 10. All right, and I divide by the negative 3, and I'm careful with reversing my symbols whenever that happens. Divide by negative 3, divide by negative 3, and I get a negative 6 is greater than c is greater than negative 10 over 3. Okay, let's put it in numerical order. Oh, something is wrong here, guys. Notice the inequalities. The compact form should never be reading greater than, greater than. Compact should always go least to greatest, so it always goes less than, or less than or equal to. Okay, with x in the middle. It can't be greater than, greater than. That shows me something's going wrong. So I'm imagining this on the number line. Here is a number line. Here is negative 6, and it's saying c is less than it, so that's this. And c is greater than negative 10 over 3. Negative 10 over 3, that's like negative 3 1/3. Here's like negative 3. And that would be c greater than that. Well, remember, and has to overlap. The compact form has to be overlapping. There's no overlap here, so it's no solution. Okay. Problem 9. Again, that last one, problem 8, is a little bit beyond. So now this is a classic absolute value inequality. We have a few steps. Step 1, isolate the absolute value bars. Okay, you don't do anything inside it. You don't work with anything that's inside the bars. You need to get those alone on their side. Well, that's already happened here. We don't need to remove anything. So step 2, decide and or. Now to decide that, remember, it's all about where is the variable. If the variable is on the less than side, it's and. Less than and. If the variable is on the greater than side, it is or. Let greater or. So in this case, it's on the greater than side. The equal to is the same rule. So if it's less than or equal to, greater than or equal to, it's still and versus or. This is clearly an or scenario. So what we're going to do is we write the word or, and then we write our two cases. Y is greater than or equal to 4.5. And remember, with this second case, we need to reverse the inequality symbol and change it to negative 4.5. But that is our solution here. And so we just need to find it in the list. Okay. Problem 10. Ooh, this one's getting a little bit ugly. So we've got the absolute value of 3j minus 1 plus 6 is greater than or equal to 0. Well, the first step is to isolate. We always need to get it alone. So I'm going to subtract 6 from both sides because I want the bars to be alone. 3j minus 1 is greater than or equal to a negative 6. Now you could stop there for a number of reasons. As one student pointed out, all of the signs here don't have the equal to part in the whole problem. So that means none of these are options. Well, that's good reasoning there. We can also stop it for different reasons. Remember, when a negative is on the right-hand side here, then we've got a weird scenario. It has to be either no solution or all real numbers. And so the Edpuzzle that you guys watched on Monday covered this. What we need to think of is that absolute value is positive, and think true or false with the idea of a positive number being greater than or equal to -6, true or false. Well, that would be true. Positives are always going to be greater than this negative number, which means we have an infinite solutions or an all real numbers. This is true no matter what, because this absolute value will always be positive, which is greater than or equal to -6. Okay, problem 11. Solve. We've got 3 times the absolute value 14 minus m is greater than 18. This is a great problem because it requires an extra step. Okay, first we isolate. Step 1, divide by 3. Now, if this was a -3, we would have to reverse our symbol. It isn't though, so we're just going to leave it the same. 14 minus m is greater than 6. Okay, now we write our two cases. First, we need to decide and or. This is an or scenario. Go back a few problems if you need help with and versus or. All right, here 14 minus m is greater than 6, or 14 minus m is less than -6. Okay, now we're going to solve it using a two-step operation. First, I would get my outside in number. I'm going to subtract the 14 from both sides. Since it's a positive 14, I just need to subtract it. Bring down what's left, which is -m, is greater than 6 minus 14, a -8. Now to finish this problem, though, we have a trick here. -m needs to be, we need to remove that negative. We need m to be isolated. So I'm going to divide by -1. And circle my symbol here because that broke that negative division rule. We now have m is less than +8. And I'm going to put the word or because I know my other answer is going to go right there. All right, so on the other side, I'm going to subtract the 14. It's the same two steps to solve. Get a -m is less than -20. And then I'm going to divide by -1 and circle the symbol here. M is greater than a +20. So let's find the one that represents that best. M is greater than 20, or m is less than 8 is right here in the middle. Okay. All right, problem 12. -4 times the absolute value of 6b minus 8 is less than or equal to 12. Let's divide by -4. Remember, one main thing here though, if we divide by a negative, what happens here? We're isolating it, but we need to still follow that rule about division or multiplication. In this case, we end up with absolute value of 6b minus 8 is greater than or equal to a -3. And now we're going to pause this problem because we see a negative here and we know, wait, whoops, absolute values are positive, greater than or equal to -3. Well, decide true or false. In this case, a positive number will always be greater than or equal to -3, so we have a true statement, which means that we have all real numbers or infinite solutions. Right. Here's a classic problem. This is just a straightforward absolute value inequality. We have h minus 5 is less than or equal to 10. First decision, is it isolated? Yeah, it's isolated. Second decision, and or. And. Okay, I'm going to copy the first case, just like normal. And for the second case, we need to remember our rule, reverse the symbol, reverse the sign. All right, that was step 2. Now we solve for h in each problem. We get h is less than or equal to 15, and add the 5 here, add the 5. H is greater than or equal to a negative 5. Awesome. Classic problem here. We just need to find our answers. Now, I noticed they put the word or, but they're never writing the word and. Super annoying. It has to be one of these three because it is an and. And we got clear answers. This wasn't, remember, if it was a negative 10, we would know it's one of the top two. It's not a negative 10, so let's eliminate those choices. Now we just need to put it in numerical order in the compact version. Remember, negative 5 is the least number there. Keep it with the less than side, or equal to h, less than or equal to 15, and let's find that answer. It looks like the middle choice of the compact inequalities is correct. Okay, final problem. Here we have a true doozy. Several steps involved to get this right. Let's break it down piece by piece. First step, is it isolated? No, the absolute value is not isolated. Let's work outside in. We need to isolate it by adding 13. And we're going to get a positive 8 here, greater than or equal to 2 times the absolute value of 3w plus 8. Okay, there we are. And is it isolated yet? No, we need to divide by 2. I'm going to divide by 2 here because I need those bars to be completely alone before I work outside or work them outside. Now I can do my two cases. First, decide, is it and or? It's and. 3w plus 8. Copy the first case right as is. And with the second case, just like we've been doing this whole time, reverse the symbol and reverse the sign. Okay, now we're going to work outside in from the variable to solve for w. I'm going to subtract 8. And I would get a negative 4. Now, some of you guys might be like, oh, it's no solution because there's a negative 4 there. No, we've already broken him free from his prison. It's okay to have negatives on the right now. The only time is once it's isolated. This is when, here's the isolated step. This is when I check to see, is the right-hand side negative? Ding, ding, ding. No. It's positive, so I can continue solving. Continue solving. And we do the rules like normal. Even if we're getting other negatives past this point, that's fine, because that's when you're just solving for your variable. Okay, I get 3w is less than or equal to negative 4, divide by 3, divide by 3. And we've got our answer. W is less than or equal to negative 4/3. Okay, on this one, I'm going to subtract the 8, get 3w is greater than or equal to negative 12, and divide by 3 to get w is greater than or equal to negative 4. Bring down my word in the middle, and once again, I'm going to start eliminating answers. First off, we decided earlier it was not going to be a no solution or all real numbers, so these are both out because of this step here. Next, we figured out too, because of that step there, that it was not or, so let's eliminate all of those. Don't get distracted by them. Finally, we need to put the compact version in numerical order, so we're going to start with the negative 4, that's my least one, with the pointy side or the less than side of the inequality, w, and less than or equal to negative 4/3. Okay, let's see what we can find here. We have a winner. It is the first and option. Negative 4 is less than or equal to w is less than or equal to negative 4/3. All right, guys, that concludes our review for the study guide on Chapter 2, Lesson 5 and 6. I thank your minds and your hearts, and I wish you, as always, a good afternoon. Bye.